Today we're going to be taking a look at what's called the greatest common factor, or sometimes you'll see it abbreviated as GCF. Now if you look up greatest common factor in the glossary in the back of the book, it says the greatest of the common factors of two or more numbers. Okay? Another way to look at that is this. It's the biggest factor that's the same between two or more numbers. So let's take a look at what that looks like just with a couple of simple numbers like 4 and 8. Okay, so the factors of 4 I know are 1 and 4, because 1 times 4 equals 4, and I know 2 times 2. So 1, 2, and 4 are the factors. I know the factors of 8 are 1 and 8, so 1 times 8. I know 2 and 4 are also factors. Now, so these are right here are the factors of 4, and here are the factors of 8. Now I'm looking for the biggest factor that's the same between them. So this is a common factor because it's the same, but it's not the biggest. Here's a common factor, 2, but it's not the biggest. 4 is the biggest common factor between those. So 4 is my greatest common factor. Now the example I showed you, the last example, was pretty simple because those numbers were fairly small. But when you get to have numbers that are a little bit larger, you're going to want to have a strategy that you use. And I'm going to show you 2 strategies that you can pick from, and you can use whichever you prefer. Let's say I have 2 numbers like 18 and 48, and I'm asked to find the greatest common factor. I'm going to start with 18 here. And what I do is I start at 1, and I say what 1 times, obviously, 18 gives me 18. Now, I want to go with my next number. Now, 18 is even, so I know 2 will go in here. So 2 times, and I think to myself, 2 times 9 is 18. So you'll notice I'm taking my numbers, the smallest number, and I'm going this way, and I'm pairing it with the number here. So 1 and 18, I times them by each other. 2 and 9, I can times them by each other. Now, I know that 3 also goes into 18 because I know 3 times 6. And you see I'm working my way to the middle. And that's another reason why I started so far apart here. Okay, and now 4 does not go in, 5 doesn't go in, and now I'm at 6. So there are my factors for 18. Now I do the same thing with 48. So I've got 1 and 48, and I'm starting way apart on these. Okay, 48's even, so I know 2 goes in there. And I think half of 48 is 24, so 24 times 2 would give me 48. Now 3, I know that 3 goes in here. Here's how I know that. If I add the digits, 4 plus 8, that equals 12, and 3 goes into 12. So I know 3 will go into 48. So I just have to figure out 3 times what? Well, 3 times 15, 15, 30, 45. So if I went one more 3, so 3 times 16, that would give me 48. So it's 3 and 16. I can see that 4 goes in here because 4 goes into 4 and 8 perfectly. So 4, and if I divided that out, I would get 12. So 4 and 12. You can see here my numbers are coming together in the middle. 5 won't go in there. 6, yes, I know 6 times 8 is 48. So 6 and 8. And now 7 would be the only number that's in between these two that's left, and I know 7 doesn't go in there. So there are all my factors for 48 right here. There's quite a few of them. Now I can find my common factors. I see 1 is common, 2 is common between those two, 3 is common, 6 is common, 9 and 18, nope. So those are my common factors, and the greatest or the biggest is 6. So 6 would be my greatest common factor. Now the other way I can do this is I can find the prime factorization for each of these numbers. So like we did the other day, we're going to get the prime factorization. I like doing the factor trees. So I'm going to go 2 and 9, and then 3 and 3. Okay, so my prime factorization here is 2 times 3 times 3. Okay, and then for 48, I know 6 times 8 is 48. And then I can break that one down to 3 times 2. I can break this one down to 2 times 4. I can break the 4 down to 2 times 2. So the prime factorization here is 2 times 2 times 2 times 2 times 3. Now I circle the common prime factors. So 2 and 2, that's 1, and 3 and 3, that's 1. Now, if there was another 3 in here, I'd circle that as well, because there's a 3 here, but there's no more 3's. So, what I do is multiply these, and I get 6. Okay, well, you could have multiplied these two. It doesn't matter because they're the same, but 6 is going to be your greatest common factor. So you can use whatever method works best for you, either this one or the one I just showed you before this. If I was asked to find the greatest common factor, or GCF, of 12, 24, and 60, here's how I would do that. So I would create the factor trees for each of them, just like I've done here. Now, once I do that, I'm going to find what are my common factors with each of these. So I've got a 2 I can match with each. Now I have a 2 here, another 2 there, so I can circle that one. 2, 2, and 2. Okay? Now I've got a 3 here, and a 3 there, so I can circle that. And now that's going to be the last one because there's no more factors in this one, so they're not going to be able to match with any of the others. So now I just take and I multiply, take any set, doesn't matter which set, because you have the same factors, and multiply them together. So 3 times 2 is 6, times 2 is 12, so my greatest common factor would be 12. So I'd have that for my answer. So here's an example of a problem where you might use the greatest common factor to find the answer. So it says the cheerleaders are making spirit ribbons. Blue ribbons come in a 24-inch spool. So there's that. Red ribbons come in a 30-inch spool, and the gold ribbons come in 36-inch spool. The cheerleaders want to cut strips of equal length and use the entire spool of each ribbon. What's the length of the longest piece of ribbon that can be cut from each spool? So you can see they found the greatest common factor here, and they did this method here, and then they said, okay, the greatest common factor would be 6 inches, or the greatest common factor would be 6. So that means 6 is the biggest factor that will go into each one of these. So we can count by 6's and we'll get to 24. So we could cut that perfectly. We could cut this in strips of 6 inches long, and we'd be able to get to 30. And we'd also be able to cut this into 6-inch strips and get to 36. And here, you'll have to excuse me, it's a little sloppy, but here I tried to show you that. So if you cut each of these into groups of 6, or 6-inch strips, it'll go into there perfectly because 6 is a factor of each one of these. So you'll see there's none left over. Count by 6's, I'll get to 24. Count by 6's, I'll get to 30. Count by 6's, I'll get to 36.